Welcome to this module on testing levels, a vital concept for every software tester. Testing isn't a one-time event, it's a layered process. Each level of testing targets a specific part of the software system. Understanding these levels helps ensure complete test coverage and a smooth user experience. Let's walk through the 4 key levels: unit, integration, system, and acceptance testing. First, we have unit testing. This is the most granular level of testing. Unit testing focuses on individual components or functions in the code, the smallest testable parts. Developers typically write and run these tests themselves. The goal is to ensure each unit performs as expected. Think of unit testing as checking the engine of a car before putting the car together. If every component works correctly in isolation, the overall system is more likely to succeed. Unit tests are usually automated and run frequently during development. Tools like Junit for Java or Nunit for .NET make this process efficient and repeatable. Next comes integration testing. Once individual units are tested, we need to ensure they work together. That's where integration testing steps in. It focuses on the interactions between components, modules, or services. For example, if one module sends data to another, integration testing verifies that the data is transferred and processed correctly. This level often uncovers issues like data mismatches, interface problems, or communication breakdowns between systems. Integration testing can be done using top-down, bottom-up, or sandwich approaches, depending on project needs. Tools like Postman, Rest Assured, and integration frameworks help validate these interactions. Third is system testing. At this stage, the complete software system is tested as a whole. System testing evaluates the application from end to end, just as a user would experience it. It checks whether the entire system meets the specified requirements. This includes functional testing to verify core features and non-functional testing to evaluate performance, security, usability, and more. The key point here is that testing is conducted in an environment that closely mirrors production. Testers do not rely on knowledge of internal code. Instead, they focus on inputs, outputs, and behaviors. Think of it like driving the fully assembled car under real-world conditions. Finally, we reach acceptance testing. This is the last level before the product reaches the customer. Acceptance testing determines whether the software is ready for release. It's usually performed by the client, stakeholders, or an independent QA team. The objective is to verify that the system meets business requirements and delivers value. There are 2 types: alpha testing, done in-house, and beta testing, conducted by a limited number of actual users. This level of testing is critical. A green light here means the product is ready to go live. Let's quickly recap. Unit testing ensures individual parts work correctly. Integration testing checks that components communicate properly. System testing validates the entire application. Acceptance testing confirms that the system is ready for users. Each level of testing builds on the previous one. Skipping a level or performing it poorly can introduce risks, delays, and costly rework. That's why understanding and implementing testing at every level is essential to delivering high-quality software. As a tester, your involvement may vary depending on the level. But knowing what each level aims to achieve and how to contribute effectively makes you a stronger, more versatile quality engineer. In the next module, we'll explore different testing methods, from black box to white box testing, and when to use them. Stay tuned as we continue building your testing expertise.